on a clear night, and the stars seem eternal, fixed, unchanging, the very picture of permanence. But every one of them is living a life. They are born, they grow old, and one day they die, some in silence, others in the most violent explosions in the universe. This is the story of a star, from a cold cloud of nothing to the atoms that became you. It begins with almost nothing, a giant cloud of gas and dust, drifting in the dark between the stars. We call it a nebula. It can stretch dozens of light years across, yet it's thinner than the best vacuum we can make on Earth, and colder than almost anywhere in the cosmos. For millions of years, it simply drifts, doing nothing at all. It is the raw material of a star, waiting for a reason to begin. Then something disturbs it. Maybe a nearby massive star ends its life in a supernova, sending a shockwave rolling through the cloud. Maybe two clouds drift together and collide. Whatever the trigger, it squeezes the gas just enough to tip the balance, and now gravity, patient and relentless, finally takes over. In the densest pockets, the cloud begins to fall in on itself. The long stillness is over. As the cloud collapses, the densest clumps pull the hardest, gathering more material and growing heavier still. Deep at the center, matter piles up and the pressure climbs. And as a gas is squeezed, it heats so the heart of the collapsing cloud begins to glow, faintly at first, then brighter. This is a protostar, not yet a true star, but its seed, growing hotter every day as gravity feeds it. The original cloud was turning ever so slowly, but as it shrinks, that spin speeds up the same way a figure skater spins faster by pulling in their arms. Faster and faster the material whirls, until it can no longer fall straight inward. Instead, it flattens into a vast, spinning disk, with the growing protostar blazing at its center. And in that leftover disk, grains of dust stick together and clump into rocks. Then worlds the same collapse that builds a star also builds its planets. At the core, the temperature keeps climbing. 10,000 degrees, a million. And then, at around 10 million degrees, a threshold is crossed. The hydrogen nuclei are crammed so close and moving so fast that they begin to fuse, slamming together to form helium. Nuclear fusion ignites. Energy floods outward, the core pushes back against gravity, and the collapse stops. A new star switches on, and its light begins its long journey out into the universe. What makes a star shine isn't burning, it's something far more powerful. When hydrogen fuses into helium, a tiny fraction of the mass simply vanishes, converted into energy by Einstein's famous equation E equals mc squared. That whisper of lost mass releases a staggering amount of energy, and a star is, in essence, a perfect balance, the outward push of fusion holding firm against the inward crush of its own gravity. For as long as that balance holds, the star shines. This balanced life is the longest chapter of all. A star like our sun will hold it for some 10 billion years, fusing hydrogen, glowing steadily, barely changing. We call this stable phase, the main sequence, and it's where stars spend the vast majority of their lives. It is a quiet, generous time, steady warmth pouring out for billions of years. Long enough, on at least one nearby world, for life to stir and look up and wonder. But no fire burns forever. Slowly, over those billions of years, the star turns its core of hydrogen into helium, and one day the hydrogen there runs out. Without fusion to hold it up, the core begins to contract again, heating as it shrinks. That fresh heat ignites hydrogen in a shell around the core, pouring even more energy outward than before. The star's calm middle age is ending, and it begins to transform into something strange and enormous. Driven by that new flood of energy, the star's outer layers swell outward, ballooning to many times their old size. As they expand, they cool and redden. The star has become a red giant, bloated, luminous, and restless. When our own sun reaches this stage, billions of years from now, it will grow so large that it engulfs Mercury, then Venus, and scorches the Earth if it doesn't swallow our planet entirely. The gentle star that gave us life will end its days as a giant. From here, a star's story splits in two, and which path it takes was decided long ago at its birth by a single number, its mass. A star like the Sun, and anything up to about 8 times its mass, will end its life gently, almost quietly. But a true giant far heavier than the Sun is headed for something else entirely, a death so violent it briefly outshines a galaxy. The same beginning, 2 utterly different endings. Let's follow each in turn. First, the gentle path, the one our Sun will take, after its red giant phase. A Sun-like star never gets hot enough to fuse the heaviest elements, so it simply lets go. Its outer layers drift away into space, glowing softly, forming a delicate, glowing shell we call a planetary nebula. Left behind at the centre is the star's bare core, an object the size of the Earth, but unimaginably dense, a white dwarf. It will cool and fade over trillions of years into the dark. Now the other path, the violent one, reserved for the giants. A massive star burns hotter and faster, and when its hydrogen runs low, it doesn't stop. It fuses helium into carbon, carbon into oxygen, neon, silicon, building up layers like the rings of an onion, until, deep at its heart, it forges a core of iron. And iron is the end of the road. Fusing iron doesn't release energy, it absorbs it. The moment an iron core forms, the star is doomed. Iron fusion steals energy instead of giving it, so the outward push fails and gravity wins all at once. In less than a second, a core the size of a city implodes, and the outer star comes crashing down behind it, then rebounds in a shockwave of unimaginable force. A supernova. For a few brief weeks, this single dying star can shine brighter than 100 billion stars combined. And in that inferno, something precious is made. The staggering energy of these deaths and the collisions of the remnants they leave behind forges the heaviest elements in nature: gold, silver, platinum, iodine, uranium, elements that no ordinary, quiet star could ever build. And then the explosion scatters them, flinging this newly minted stardust across light years of space, seeding the galaxy with the raw ingredients for everything still to come. But the dying giant leaves something behind. Its collapsed core is crushed so hard that protons and electrons merge into pure neutrons, packing the mass of a whole sun into a ball barely 20 kilometers wide. A neutron star, the densest matter in the universe, where a single spoonful would weigh 1 billion tons. Many spin hundreds of times a second, firing beams of radiation from their poles. As those beams sweep past Earth, we see them flash again and again, a cosmic lighthouse we call a pulsar. And for the very largest stars, even that isn't the end of the collapse. If the core is heavy enough, nothing known can hold it up, not even the defiance of neutrons. It keeps falling and falling until it vanishes behind a one-way door in space itself. A black hole, a region where gravity is so extreme that not even light can climb back out. The most massive stars end their lives by carving a hole into the fabric of reality. And yet, this is not really an ending, because every atom the star forged, and every atom its death scattered, drifts back out into the dark. For ages it wanders, and then, somewhere, it is swept into a new cold cloud, and the whole story begins again. New stars ignite from the ashes of the old. New planets form in their disks. The carbon in those worlds, the oxygen, the iron, all of it was cooked inside stars that died long ago. Our own sun is a later generation star, and the Earth and everything on it was built from that recycled stardust. The iron in your blood, the calcium in your bones, the oxygen in every breath, each atom was forged in the heart of a star and scattered by its death long before the sun was born. You are not separate from this story. You are made of it. You are the universe, brought to life, looking back at itself. Pale blue speck, tiny facts about a vast universe.